Problem number 56, page 633, equilibrium section of the text. In this problem, we're given this balanced chemical equation. It's a three-part problem, A, B, and C. We're going to address A first. In part A, we're told that the initial pressure of N2O4 is 4.5 atmospheres. The equilibrium constant for this reaction is 0.25. We need to determine the equilibrium pressure of the N2O4 and the NO2. To determine the equilibrium concentrations, we're going to need to set up an ice box. The initial concentration of the N2O4 gas was 4.5 atmospheres. Initially, there was 0 NO2. The change in concentration is minus X for N2O4 and plus 2X for NO2. Combining the initial and the change, the equilibrium concentration for N2O4 is 4.5 minus X, and the equilibrium concentration for NO2 is 2X. Now these two expressions here and here are the equilibrium concentrations for N2O4 and NO2, but they're completely meaningless unless we solve for X. So if we can solve for X, then we can get an actual value for the equilibrium concentrations. To do that, we're going to use the equilibrium constant. We're going to write an equilibrium constant expression for the chemical reaction and then substitute in the equilibrium concentrations that we determined from our ice box. Now we have this mathematical expression that we can use and solve for X. So we have to simplify this a little bit. We're going to multiply the bottom we're going to multiply both sides of the equation by the denominator. Then going to distribute 0.25 through this. Move everything to one side of the equal sign, and we end up with a polynomial. Now to solve this polynomial, we need the quadratic formula. Using the quadratic formula, substituting in the coefficients that represent A, B, and C from the polynomial into the quadratic formula. Solving for X, you get two solutions. We now have to figure out which X to use. Now what's here is everything is the same on both sides. The chemical equations are the same. The equilibrium concentrations are the same. What's different is the solution for one X from the quadratic formula that we just solved and the other solution of X from the quadratic formula that we just solved. I'm going to substitute both of these X values in. On this side, you end up with an equilibrium concentration of 4 atmospheres in 1 atmosphere. Substituting in X2, this solution for the quadratic formula for our polynomial on the previous slide, substituting this in here and here, you get a solution of the equilibrium pressure of this gas is 5.06 atm, and this pressure is negative 1.125. It's impossible to have a negative pressure at equilibrium. So this solution is invalid, making this solution for X invalid. So the correct solution for X is here. So our equilibrium pressures of N2O4, 4 atmosphere, equilibrium pressure of NO2, 1 atmosphere. The solution for 56A, we are told to start with an initial pressure of 4.5 atmospheres of N2O4. Then we're supposed to calculate what the pressures would be at equilibrium. So those pressures are 4 atm and 1 atm. This is now 56 part B. Starting with an initial pressure of 9.0 atm NO2. equilibrium constant is still the same equation. So to determine the equilibrium concentration of the gases, again, we need to use an icebox. This time we are told initially we have 9 atm NO2. No initial concentration of N2O4. Now I'm going to consider that this reaction, since we're starting here and we're going this way, I'm going to just consider this the reactant, and I'm going to call the negative, since we're going to be using this to the NO2 to make N2O4, the concentration is going to go down. So I'm going to have the negative sign here for my change, negative 2x. And then since we're producing N2O4, the change here will be positive x. So setting up the icebox, concentration at equilibrium of N2O4 is x. The equilibrium concentration of NO2 is 9 minus 2x. Now that we have these two equilibrium concentrations, all we need to do is solve for x, and then we can figure out the exact values. We're going to do that using the equilibrium constant and the equilibrium expression. So writing an equilibrium expression, substituting in the equilibrium constant and the equilibrium concentration values, we now have a math equation that we can solve for x. We need to solve for x, so you're going to get rid of the fraction, multiply both sides by x, expand this, FOIL first, outside, inside, last, get everything to one side of the equal sign. You want combine like terms, you end up with this polynomial. To solve for x, you need the quadratic formula. Substitute the variables a, b, and c into the quadratic formula. Solve for x. Determine both solutions for x. We need to figure out which x solution from the quadratic formula makes sense for our problem. Substituting the first solution in for x, 5.0625. You end up with a negative pressure for NO2 at equilibrium, which is impossible, making this x solution invalid. Using this x solution, substituting this in for x, you get two answers that are realistic: 4 atmospheres and 1 atmosphere. Now the solution for question number 56, part B, when starting with an initial pressure of 9 atm NO2, you end up with an equilibrium pressure of 4 atmospheres for N2O4 and 1 atmosphere for NO2. This is the solution for number 56, part C. So comparing the answers, part A and B, you have the same concentration at equilibrium, whether starting with 4.5 atm of N2O4 or starting with an initial pressure of 9 atm NO2, as long as they were in stoichiometric amounts. So the stoichiometric ratio between the reactant and the product is 1 to 2. So doubling here, 1 to 2. All right, questions?